Our next presenter comes from ChemAxon, Tímea Polgár. She's an application scientist based in Hungary, and her talk is going to cover our Markush technology and how to explore patent space.
Okay, so the presentation is about the Markush project at ChemAxon from the very beginning, and the existing technology as well. I just have a nice figure over here. You can end up, if you're a patent officer, and end up a situation like that when the patent office simplifies regulations, so we might be able to give you a hand. So the project started at 2005, and the first prototype was released in half a year. The first real release, I think 3 years later, and we started the cooperation with Thomson Reuters in 2010. And today, what the Markush team is working on is the performance improvement. They are expanding the feature list, and they are also working on computer cluster support. So what kind of chemistry can we find in patents? I think all of you know the answer, but just have a look at this Markush structure. It's not easy to understand by sight. It can be very complex. The cooperation with Thomson Reuters looks like this. So Thomson Reuters provides the content, they provide the Markush structures, the patent text data, the exemplified structures, and ChemAxon is the software provider. So on your hardware, installed on your hardware, you can execute these Markush searches. ChemAxon also provides technical consultancy to help you set up the system. This is the proposed architecture of the system. What we offer or propose is the Instant JChem as a client, and under the client you see the Oracle and the JChem server. So this does the search itself. What kind of Markush features can the ChemAxon software handle? This is a quick list of the features. Of course, we can handle R groups, multiple attachment points. I don't have the pointer. And also up to thousands of R group definitions. So it allows you to manage combinatorial libraries as well. Atom lists, bond lists are treated, position variation bond, when this bond can be attached to the grade area. Link nodes, repeating units also handled. Homology groups, which are called superatoms in the MMS, or Cass calls them generic definitions, are also handled in ChemAxon, in the ChemAxon software. And one great advantage, what clients usually say, is the easy to understand graphical representation. So what it looks like at the moment. This is the Instant JChem interface. I'm sure everyone knows. This is a form view, and you see here the Markush structures, the DCR structures, example structures, and also the patent, the text data on one form, and it's quite easy to analyze and review one patent in Instant JChem. The current viewer in 5.6 is the Markush Viewer, and it is also a standalone application. I just switch quickly to here. So this is the Markush Viewer. I opened a VMN file from the Thomson Reuters data base, and so these are just the basic visualization options. Below you see a nesting view, and there are helping nodes and lines. And also this is the whole Markush structure and the fragments. If I click on, something is not really good with the resolution. Oh, okay. So this is the scaffold, and these are the R groups, and below you see the nesting view. So when you have a database filled with Markush structures, you can execute a search. This is also the Instant JChem interface, the query builder. You can use the Marvin sketch for query drawing. What kind of searches can we do? You can do a full structure search, substructure search. There are other operators like these and or other operators for text. Numerical values can also be applied and used with the structure search. The Markush search technology, the query features, sits on the top of the generic chemical structure search and the general ChemAxon search technology. And why I'm mentioning that? Because the Markush query feature list is expanding, and at the moment we don't have as many as for generic structure searches. I quickly run through this list. When you draw a query structure, you can include atom list, bond list. This is an atom list. Bond lists are here. Atom bond topology can also be used. Stereochemistry, aromatic, aliphatic atoms, link nodes, position variation bonds, simple R group queries, substitution count, block substitution on atoms, ring bond count, equal homology translation. Broad translation is switchable now, and hydrogen count on atoms. I think Tim already mentioned in the morning that in Instant JChem you can do R group decomposition, and Instant JChem now is able to create a Markush structure. So this is the R group, this is the query and the R group table and the resulting Markush structure. So when you have the hit list, you can use these formatting options. You can create statistics, the conditional formatting. You can plot your results, sort your hit list, and archive or combine the hit list. And in Instant JChem, there is also this relevant R group visualization option. So here you can, after a search, visualize only those R groups which contain the query structure. So this is only the scaffold, relevant R groups, and the whole Markush structure. Where is my query structure? When you have a complex Markush structure and you do a search, it's not always obvious where is the query structure in the Markush structure. So therefore, ChemAxon developed the so-called Markush structure reduction method, which will show you where the query structure is located in the Markush structure. So after searching what else we can do with the Markush structure, you can enumerate the Markush structure. You can do it in Marvin and Instant JChem, and these are the options in Marvin for the enumeration. So a random full enumeration can be done. You can also calculate the library size, and there are other options helping you to analyze the results. This is the Instant JChem interface, and already been said that post filter can be applied for the enumeration results, and these are the display options which are available in Instant JChem. So we can show the R groups, you can color you can align and partial clean the Markush structure, and the coloring can be also set. That means that the query is colored differently. Markush search and the Markush technology is also available in Knime. So this is an example workflow, and the graphical user interface is very similar what we have in other applications. So Markush search, Markush enumeration, and Markush structure generation can be done in Knime. Finally, I would summarize what's happening today. So what are the most important take-home messages about the Markush technology? So one strong point is the user-friendly representation. The modern technology, Java.NET and web-enabled, and maybe or probably one of the most important ones is the gradual or predictable speed-ups. And it is now being scaled up for the full Markush MMS database. The hosted evaluation service, the computational cluster support, which is planned for the near future, the growing chemical feature list, and finally the continual dialogue with users and evaluators. And we are open to have other Markush forum participants. Oh, I might need to drink. So please join our Markush forum. Thank you for your attention.
Thanks, Tímea. Do we have any questions?
Obviously, Markushes can be used for clusterization. If you have a set, you can ask this question, right?
Clustering?
Yeah, clustering.
What do you mean exactly?
Or you can use them to, say, set up distances in a better sense, say, than any model.
I don't know, Szabolcs, can you comment on that? Or Mitso?
Is there any tools for that? That was my question.
Well, I don't think I understood correctly the answer.
This is something close to similarity, obviously. Although this similarity is in the sense of a dendrogram or cluster, right? So do you have any tools where you use this, not for query, but if you have a set, say 1,000 compounds, can you come up, search extensively this data set, come up with a subset of Markushes, and then use whatever for clustering? Do you have any tools? What do you think about it?
Only have a workaround, like first do a random enumeration and get a representative set of specific structures, and then you can cluster all those structures and do similarity analysis and things like that. We do not have any similarity functionality for the Markush structure itself.